All right, today we're going to learn some different types of solids and how to tell them apart. So everybody should be on page 583 in your books. You need to be on page 583 to look at the chart with me, because although I am pretty good at drawing, I'm not that good. So I will not be drawing a lot of these figures. So go ahead and turn in there to in your book to page 583. All right, so in example 1, all right, I'm just trying to tell the solids apart. But before I can do that, I need to look at what are the differences between the solids. So in the prism, in the top chart, do you see where I am on the top of page 583? The prism is formed by polygons. Remember, a polygon has at least 3 sides, and all of the sides connect to form line segments. A polygon does not have curved sides. All right, and then the prisms have 2 congruent bases on the top and bottom. Okay, now the bases are very important because I classify the prism by its base. In this case, what shape is the base? What shape is it? It's a triangle. So I would call this prism a triangular prism, specifically. Now, in the pyramid, you see again with a pyramid, it can have any type of shape for its base. In this case, it has a rectangle for a base, so I would call it a rectangular pyramid. Another thing that makes a shape a pyramid is you notice that all of the sides are what shape? They're all triangles, and they meet at a point at the very top, which I call the vertex. So that's a pyramid. Then you have a cylinder. A cylinder has 2 circular bases. A cone only has 1 circular base, and it has the point that meets at the top as well. And then you have a sphere, which is basically, a circle, and all of the points on the outside of the sphere are the same distance from the center. All right, so those are your shapes. You need to know them. Now, for example 1, example 1a, what type of solid do you think that is? What type of solid is it? Daniel? It is a cone. Because, again, it has a circular top. It has a point at the bottom. It's a cone. And it actually is an ice cream cone. So that kind of makes it even more obvious. All right, so that's all you have to write is example 1a, it's a cone. What about 1b? What's 1b, class? Pyramid. It is a pyramid. Very good. It's a pyramid. What about example 1c? Cylinder. It is a cylinder. Okay, and that's it for example 1. Any questions? All right, now let's dig into this classifying prisms and pyramids a little bit deeper. Now remember what I just said. We classify them by their bases. We classify them by their bases. So on example 2a, the first question I ask myself is this a prism or a pyramid? And example 2a is what? Is it a prism or a pyramid? It is a pyramid because all of the side faces are triangles, and they all meet at one point at the very top. So it is a pyramid. But now I need to figure out what kind of pyramid it is, and I need to look at the base to figure that out. How many sides does my base have? It has 5. What polygon has 5 sides? A pentagon. Now, whenever I'm describing the type of pyramid, I'm going to add an AL to the end of that polygon name. So this would be a pentagonal prism. If it had 6 sides, I would call it a hexagonal prism. You just add that AL. If it had 8, it would be an octagonal. Pentagonal pyramid. If I said prism, I did not mean to say that. Okay, a pentagonal pyramid. Now on B, is that a prism or a pyramid? What is it? Prism. It is a prism, first of all, because I don't see any triangles, and I don't see a vertex at the top. All right, so it's a prism. Now I need to figure out what kind of prism. So I need to look at the base. It is a rectangular prism. Now, without knowing the exact dimensions, you kind of just have to use your eye on that one, but it is longer than it is tall. Okay, so you would say a rectangular prism. Rectangular prism. Rectangular prism. All right, any questions about classifying the type of prism and pyramid? Any questions about that? All right, now I want you to look at these three bold-faced words highlighted in yellow right above example 3. We have faces, and those are the sides of the solid. We have edges. Those are the lines that are formed when two faces meet, each other. And then we have a vertex. And a vertex is the actual point where the edges meet. All right, so in example 3, we're going to count how many faces, edges, and vertices we have in this figure. All right, in example 3. So here's my figure. Now, a face is what you see right here in the front. Okay? See what I'm highlighting? That's a face. So if I know that this solid has a front face, it also has a face in the back, right, that I can't see. Do you agree? If it has a front, it also has a back. So how many faces is that? Okay, if it has a right side, it also has a left side that I can't see. So that's 4 faces. If it has a top side, it also has a bottom side. So how many faces do I have?
6.
I have 6 faces. 6 faces. All right, now let's talk about the edges. Okay, the edges. Now, an edge is where the two faces meet. You see what I'm highlighting in blue? Okay, so you see that edge is where the front face and the right face meet. That's one edge. So I have 1, 2, 3, 4 edges in the front. I've got 3 more on top, 5, 6, 7, 8, 9. And then how many edges do I have that I can't see? I have 2 more on the bottom and then 1 on the other side. So that is 12 edges. 12 edges. 12 edges. Last but not least, the vertices. The vertices are the points where the edges meet. So how many edges actually meet at that vertice that I just... 3. Okay, so there's not going to be that many vertices here. I have 1 vertice, 2, 3, 4, 5, 6, 7. And is there one that I can't see?
Yes.
Yep, there's one in the bottom back. So that is 8. So there are 8 vertices. Okay, and that's how I identify faces, edges, and vertices of solids. And if you understand that, that's everything you need to know for 12.1.